question. That's what it says here. It says you have three six-sided die that you use to create a geometric series by randomly throwing the die. The one die is red, the one die is blue, the third die is green. So I think they meant to say the one die is red, the second die is blue, and the third die is green. And then they said here the number on the, what do they say here? The number on the what? The number on the red die represents the value of the first term in the series. You then take the value of the blue die and divide it by the value of the green die, generate the common ratio. Then he says, what is the probability that if you what is the probability that if you sum the series to infinity, it will converge on the number 10? Wow. Oh yeah. This question just makes me laugh because obviously the whole thing is just a bit crazy. But without worrying too much about it yet, the one thing you can obviously definitely do for yourself is generate the sequence, see what the sequence looks like, and then once you've gotten what the sequence looks like, you can delete the rest of the question. So this sequence says the number in the red die represents the value of the first term in the series. Okay, so the number in the red die, we don't know what it is, right? But then it says here, you then take the value of the blue die and divide it by the value of the green die. Whew, generate the common ratio. What is the probability that if you sum the series to infinity, it will converge on the number 10? Hi, man. This question just seems so crazy, but it literally doesn't seem like it even makes sense. It literally doesn't seem like it makes sense. But obviously, I'm like, the only thing there is to do is to read it from the beginning. It says you have three six-sided die, right? That you use to create a geometric series by randomly throwing the die. Okay, then it says the one die is red, the one die is blue, blah, blah, blah. Okay, yeah, so the thing is, what we can safely say is, right, from, let's say T1 here. T1, whatever T1 is, it is either the number 1, 2, 3, 4, 5, or 6, right? It's a number either from 1 to 6, guaranteed. And then what we do know is the second number is going to be what do you call? The second number is either going to be, it's going to be a number that is generated by taking whatever green is divided by whatever let's see here, they say here, you take the value of the blue die and divide it by the value of the green die to generate the common ratio. So the idea is, if this sequence has a sum to infinity, right, whatever happens, the common ratio has to be bigger than -1 and it has to be smaller than +1. There's no other way, meaning that the common ratio can only be something like 1/6. It can be something like 2/6, 3/6, 4/6, 5/6, right? It can only be one of these numbers. But obviously it can also be something like 1/2, 1/3, 1/4. Going on. Oh, excuse me. Yeah, so R can be a lot of numbers, but it just means R just has to be a number between -1 and 1. So yeah, this question is definitely a bit crazy. The only other crazy thing is that there is no mark allocation. There's no mark allocation. The mark allocation is what is this? Is left out, of which the mark allocation would have made life a bit easier, like literally. So there's that. Yeah, this is just crazy, bro. Anyways, so I've only just looked at this question for like a few seconds, and without overthinking it, I think the idea is to just work backwards. So working backwards, They asked you, what is the probability that if you sum the series to infinity, it will converge on the number 10? So what we already know is if your sum to infinity is 10, right? This is what we have. Your sum to infinity is equal to 10. If your sum to infinity is equal to 10, just redo this nicely. Sum to infinity equal to 10. It just means that 10 is equal to a over 1 minus r, because remember, the sum to infinity formula says that a over 1 minus r is what you have as your the sum to infinity. So if they say what is the probability that the sum of the series infinity will converge on the number 10, for it to converge on the number 10, right, we have to find out, we know that a has to be a certain number, and then r has to be a certain number also. But the one thing that we can do is a can only be one of 6 numbers. That's what we know. R can be multiple values, but let's see what we can do. In this situation, I mean, like, funny enough, you would be thinking to yourself, why don't we just put in values for a, like 1, 2, 3, 4, 5 until 6, and then just get multiple values of r? Well, we could try that. Let's just try that and see. Let's try where a is a 1. If a is a 1, then your value of r is, let's see, cross multiply here. You're going to have 1, this bracket here times this here times 10, right? It's going to be 10 minus 10r. You're going to solve for r. This is going to go over. You're going to have 10r here. It's going to go over. You're going to have 10 minus 1. This is like 9. 10r here. So if you divide by 10, it's like, let's see here, r can be, what you call, r is 9 over 10 if your value of a is a 1. But the thing is, this here is a value that is somewhat almost, we cannot necessarily have 9 over 10. It's not a valid option because the numbers on the die is numbers from 1 to 6. So you cannot have any value that is going to give you 9 over 10 in its simplest form. But anyways, let's try a as a 2. If a is a 2, let's see, we're going to have 2 here, 1 minus r. We're going to cross multiply as we said. 1 times 2 is a 2. 10 times this bracket here. We have 10r. If you move the 2, you're going to get 8 here. And then here, your 8 over 10. Let's see what this gives us. This is going to be 5 over 4. Yeah, this is a valid R value. And you may be thinking to yourself, but where is this all going? Like literally. Because we're going to do this like 4 more times. But I don't know. This is more like a last ditch kind of approach. But let's see, 10 here. If a is a 3, 1 minus r, 10 minus 10r equal to 3, and then this is going to be like 10r, 7. 7 over 10 is not a valid option for r, but then the others, let's try, we have 4, 5, and 6. So if a is a 4, let's see what this gives us. 10 minus 10r is equal to 4. Then here, 10r, this goes over, that's like a 6. And then here, that's like 6 over 10. It is like r. This in the simplest form is 3 over 5. So this is another valid option for r, right? And then if you try out 5, you're gonna have 5 over 1 minus r, right? 1 minus r. And then here, if you cross multiply, as we said, you're gonna have 10 minus 10r, and then 5. This is gonna be 10r. This goes over, maybe 5. 5 divided by 10 is a half. And that is definitely a valid option because to get a half, you could easily have had 3 over 6 as your combination. And then we have one more to test out, right? Which is 6. So 6 is like 6 over 1 minus r. And then if you cross multiply, you're going to have 10 minus 10r. The 6 here. 10r here, the 6 goes over to the left. That's like what? 10 minus 6, right? That's like 4. And here you're going to have 4 over 10. then you're gonna have 2 over 5. So out of all these options, right, because A can only be one of 6 numbers. So we said if A is a 6, right, this has to be the value of R for your sum to infinity to be a 10. If A is a 5, this has to be, if A is a 5, this has to be a value of R for your sum to infinity to be a 10. If A is a 4, this has to be your value of R for your sum to infinity to be a 10. This one does not qualify because we cannot, in our options, right, for the numbers on our die, we don't have a 7 or a 10 or anything that can give a 7 over 10. This one is valid. So we know that if A is a 2, this is what would cause us to have a sum to infinity of 10. And then the 1 doesn't work. So there's only 1, 2, 3, 4. 4 values of R that produces sum to infinity of 10. So let's see. If you read the question again, what is the probability that if you sum the series to infinity, it will converge on the number 10? So the probability that it will converge on the number 10, I mean, you may be thinking to yourself, okay, fine. Technically speaking, right? You have to now think to yourself, okay, fine. You have to ask yourself, what is the probability that you get the number 6? Well, you have to ask yourself this scenario, right? You have to ask yourself, what is the probability of getting a 1, 2, 3, 4, 5, 6? So the probability of getting a 1, a 2, a 3, a 4, a 5, and a 6, all these are equal probabilities, right? There's 1 over 6 chances, 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 1 over 6 chances. After all this, you have to think to yourself, the probability of getting a 1, after getting a 1, you have to ask yourself, what is the probability of getting what you may call yo, this is actually kind of crazy. The reason why I say this is kind of crazy is because after getting a specific value for A, right, your common ratio, you have to think of it as, you have to think to yourself that your common ratio is, as we said, it is determined by what is this? The blue. They say it is determined by the blue die. It says that you then take the value on the blue die and divide it by the value on the green die. So the thing now is, we would need to be asking ourselves, okay, fine, after getting, the options are all these numbers here, 1, 2, 3, 4, 5, 6. We said that of these 6 options, there's only 4 that can ever take us, to the promised land, for lack of a better word. 6 can take us there, 5 can take us there, 4 can take us there, and then 2 can take us there. So the idea now is we would be thinking to ourselves, okay, fine, we have all these numbers as options, but then now, what are the different probabilities of our different values for R? Because the combinations, right, of our value of R, they're just so many. Because you can have 1 over 1, 2, 3, 4, 5 until 6. And then you can have what you call 2 over 1, 2, 3, 4, 5, 6. And then you can have 3 over 1, 2, 3, 4, 5, 6. Then you can have the combinations are so many. But let's just see how many combinations we can actually have for our value of R. Let's find out how many combinations we can have for our value of R. I guess this is where, even the fundamental counting principle may come into effect, because we need to find out how many combinations of R we can potentially have. So what you can do for yourself is, you can ask yourself, okay, fine, logically speaking, right? You can almost think of these as like, yeah, this is good. This is actually kind of crazy, because you wanna think to yourself, fine, you can have 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9. I mean, you can have 1 over 1, 2, 3, 4, 5, 6. You can have 2 over 1, 2, 3, 4, 5, 6. You can have 3 over 1, 2, 3, 4, 5, 6. You can have 4 and then 5 and then the 6. And then you can have it the other way around, like where, no. Let's put it this way. The 1, right, you can have it over 1. You can have it as 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, or 1 over 6. And then a 2 can also be over 1. And then it can also be over 2, over 3, over 4, over 5, over 6. And then the same happens for the 3, and the same happens for the 4, same happens for the 5, the same happens for the 6. All these will get a chance to be over all these numbers from 1 going to 6, from 1 going to 6, from 1 going to 6. All these will all get a chance to become they'll all get a chance to be over 1 going all the way to 6. So if you think of the total number of R values that we have, right? You can see here there's 1, 2, 3, 4, 5, 6 of them, and then there's 6 of them, right? And then so it's technically 6, 12, 18, and then we have like 24, and then we have like 30, then we have like 36. So there's like 36 values of R that are possible. You see? Now, the one thing you want to think to yourself is you can either get 1, 2, 3, 4, 5, or 6, right? So after getting each of these numbers, say you got a 2. After getting a 2, there are 32 options, right, of R value. But regardless of us having 32 options, of those 32 options, there's only 4 that would no. Of those 32 options, right? The only one that would result in a sum infinite of 10 if you got a 2 is this one over here, which is like the 4 over the 5. And that 4 over 5, there's only one option like that out of 36. You see, there's only one option like that out of 36 that gives you a sum infinity of 10. So here, the 4 out of, let's see here, for a 2, right? We said 4 out of 5 will work. So 4 out of 5 will work, right? And the probability of getting that one is just 1 out of 36. Now, for the 4, we know that there's also a 1 out of 6. There's also a 1 out of 36 chances that we get 3 over 5. And then for the 5, there's also a 1 out of 36 chances that we get 3 over 36. Let's put this here. There we go, 3 over 36, right? So let's see here, 3 over 36. 3 over 6, there's only a 1 out of 36 chances that we get that. And then for the 6, if you got a 6 the first time, it's 1 out of 6 chances. But then now, for you to get a 2 over 5, for you to result in you getting a something to the 10, the chances of that happening, as we already also stated, it is just 1 out of 36. Now, the funny thing is, oh no, yo. I think this one we have to reconsider this one, because there are multiple options to get a half. This, I mean, there aren't really multiple options to get 4 over 5. This, there aren't really multiple options to get 3 over 5. This, there really aren't multiple options to get 2 over 5. But then for a half, I mean, there are different combinations. I mean, like 4 over 5 gives a half, right? And then 3 over 6 also gives a half. Let's see, 1 over 2 also gives a half. 2 over 4 gives a half. 3 over 6 gives a half. So for the half, there's actually 3 options, right? Out of the 36 that, I changed the wrong one. For the half, there's actually 3 options, right? That will give you what you may call a fraction of a half, because the idea here is the fraction that's a half, not necessarily the number 3 over 6. This number just has to be a half, because as long as that number is a half, it will work out. You see, as long as r is a half, it will what you may call work out. So that's what we need to keep in mind, right? That our value of r, there are multiple times that it can potentially be a half. But then for the others, there aren't really a lot of ways that we can get those particular values. But yeah, so from there, we need to think to ourselves, okay, fine. The probability that you get a 2 and then you get a 4 out of 5 as your common ratio, the probability of that happening is just 1 over 6 times 1 out of 36. And then the probability of getting a 4 and then this value, it is just 1 out of 6 times 1 out of 36. The probability of getting a 5 and then this value is just 1 out of 6 and then times 3 over 36. The probability of getting a 6 and then this value, it is just 1 out of 6 multiplied by 1 over 36. So all that being said, right, the probability of this happening plus this probability plus this probability plus this probability, we have to add them all up after putting all those values into our calculator. So let me just grab this calculator. This is actually quite a very, very interesting question. It's kind of weird knowing that it's going to the what you may call the IG page, but it's fine. I mean, like, it is worthy. It is worthy. Just a crazy question. But anyways, 1 over 6 here multiplied by 1 over 36. This is equal to 1 over 216. So 1 over 216. And then we have here again 1 over 216. And here we also have 1 over 216. No. That one is not going to be 1 over 216. It's only the last one also that's going to be 216, 1 over 216. This one, going to be 1 over 72, 1 over 72. So yeah, after doing all this hard work, this answer seems quite interesting, but the logic behind it is all there, you know. So you're going to add up these probabilities. You see, 1 over 216, we have 3 of those, right? We have 3 of these ones. We have 3 of these ones, right? And then we're adding 1 over 72. So what does this give us? It gives us 1 over 216 times 3. Then we have here plus 1 over 72. That's going to be 1 over 36, which is quite awkward, but mathematics does not lie. So with all this being said, right, the probability that we get, I said here, what is the probability that if the sum to, what is the probability that if the sum of the series infinity, what is the probability that if the sum, or if you sum the series to infinity, it will converge on the number 10. So the probability that it will converge on the number 10, it looks as though it is just 1 over 36. The reason for that is we said in the beginning, the probability of getting 1, 2, 3, 4, 5, or 6 is just 1 out of 60. But then for you to then get a sum infinite of 10, it can only be specific values of r's after specific values on your die for the first die. So with that being said, I mean, also because you're dealing with like different, when you say die, it's like a dice, but plural. But then the thing is, the point is, only 2 is the first number you get, and only 4 and only 5 and only 6 can potentially eventually get us a sum infinite of 10. But then for those numbers to do that, the value of r has to be a specific value. So we said for r, for this 2 to produce a sum infinite of 10, this is what the value of r has to be. And there's only 1 out of 36 chances that we get that. And then for the 4, we said the value of r has to be this number. And then we can only get this number 1 out of 36 times. And then for 5, for it to produce something of 10, the value of r has a half. Now for us to get a half, there are 3 options, 3 out of 36 options that we get a value of r of half. So 6, it has to go with this value of r. Now, if we are to get this value as a value of r, this is the probability of getting that. So we say the probability of getting 2, 4, 5, and 6 is just 1 out of 6, right? And then you have to multiply it with the probabilities of getting these numbers. So these are the probabilities of getting something infinite of 10, something infinite of 10, something infinite of 10, something infinite of 10. So you add up those probabilities, you see, which gave us 1 out of 36. So this answer is quite dope, quite cool. This could easily be an 8-mark question in an exam, in my opinion, because yeah, it is quite interesting. But yeah, man, it's a cool question. Cool question.